Okay, I want to welcome you all to this month's meeting of the Nashville Microsoft Azure User Group. That's our logo on the screen and our website address. And now we've got a YouTube channel. So we're going to be posting this video along with other videos we have on the YouTube channel. Bang. Oh, waiting in the lobby. Okay. So some of you are new to the group. Some of you I recognize have been with the group for a while. So this is our mission. We're all about learning about Microsoft Azure, educating, informing members about everything having to do with Azure. Again, a lot of words here, but basically it's just we're all Azure people. Okay, and providing a forum for open discussion and informal networking among the membership was a lot easier when we had on-site meetings. Obviously, for the time being, because of the pandemic, we're only doing online meetings. Logistics, again, we meet every third Thursday at 6 o'clock, normally at Microsoft, where we have food and networking, and then we have a presentation. Obviously, we can't have food and networking if we're meeting online, so we're not doing that. We have over 1,500 registered members in the group, but we're still looking for more members. We want to, get everybody that has anything to do or any interest with Azure here into the group. So tell your friends and coworkers about us, and bring a friend to the meeting if you can. We're always interested in knowing what Azure topics you're interested in, so let us know that as well. This is our board of directors. I'm Bill Zack. I'm the group founder and president. Roger Dahlman, who's on the call, is co-founder and vice president of the group. I'm an Azure architect. Roger is an enterprise architect with Deloitte. Tim Warner's on our board. He's a board member, and he's also a Microsoft Azure MVP, a Pluralsight and book author. You guys have probably heard of Tim or met Tim here in Nashville at one point or another. Okela Allred is a board member and a director of the academic outreach. She works with the colleges and universities in the area to get student members into our group. Matthew Puckett is a Microsoft Cloud Solution Architect. He has been our sponsor for Meeting Space from the time we started meeting back in 2013. And Jack Hagler from Vaco has been our permanent refreshment sponsor since 2013, approximately 6 years. Naturally, we're not doing refreshments tonight. But these are our sponsors, as I said, Microsoft, Vaco. Tim is providing the Teams subscription that we're using to stream video. And so we'll be using his Teams subscription for the time being. We will take the video and post it in our Teams channel. Okay. We are putting together a sponsorship program. We don't need meeting space and we don't need food, but Roger is taking the lead on talking to companies that might want to sponsor a meeting, provide a gift card or some stuff to raffle off in exchange for 10, 15 minutes at the beginning of a meeting to talk about their company or their product. So if your company is interested, please get in touch with Roger. You see his address there. I will post, by the way, I will post the slides at the end of the meeting so everybody can see what we talked about. Click. For upcoming meetings, we're planning something a little bit different. We're actually going to have a series of meetings on Azure DevOps, and these are just some of the topics that we'll be covering in those meetings. We already have about 4 presenters lined up to present on various topics related to DevOps. Hopefully, we'll focus on how people use it, proven best practices and so forth. So we're looking forward to that. That will start in June at our June meeting. Again, thanks to our sponsors. We've talked about this, no need to repeat it again. What happened? Oh, I'm going backwards. That's what happened. Okay, so anyway, tonight's topic is an unusual one in that I don't usually present to the group. Like I might present to the group maybe once every 6 months or so, but I like to get other people in the community to present to the group. And so far, we've had no scarcity of folks presenting that are willing to present. But if you are interested, let us know. and we'll work it out. We'll get you to be a presenter. And this is the point at which I would normally introduce tonight's presenter, but since that's me, what I'm going to do is actually just bring up my deck and start. Okay, let's do this. By the way, if there are any questions, put them in the chat. Roger will be monitoring the chat for us, so he'll let me know, interrupt me if I keep talking. Again, we're going to talk about Azure, what to use when. This is our technical agenda. Hopefully we will get to all of this. We may not get extremely deep on each subject, but we'll try to give you enough of a background on the Azure features that are out there so that you can have a leg up on deciding what you should be using and what, for what solutions, what applications, and what situations. A little bit about me. Again, there's a lot of words here. I'm an Azure architect here in Nashville. I worked for Microsoft for 6 years, discovered Azure, became an Azure freak, and worked. I was in a team at Microsoft at launch that was one, that focused on Azure. Founded this group back in 2013. I've published books and white papers and stuff, and I do a lot of presentations at conferences. Recently, I was appointed the chairman of the Nashville Technology Council Tech Meetup Leaders Peer Group, which is a fancy name for saying that we have a committee that tries to help all the user group leaders in the area with their groups. We do things like sponsoring refreshments for them when they don't have a sponsor and so forth. Okay, the Azure Cloud. The Azure Cloud is big. It is almost impossible to keep this presentation up to date. Yesterday, I heard at Build, I attended the Build conference, which was done online yesterday. There are now 61 regions worldwide, so a few more regions have been created. It's available in 140 countries. There's 100 plus data centers and 44 express route locations. And we'll talk about what express route is. Billions of servers. They have one of the top 3 networks in the world. In fact, Microsoft actually has a private backbone network, unlike Amazon and Google and some of the other folks. Okay, they have some huge virtual machines. Later we'll talk about virtual machine sizes, but they go up to 12, 200, incredible number of processors and RAM. They even have Cray supercomputers if you have a specialized application that needs that. And this is the same network that powers Azure, but also Microsoft, Office 365, Bing, and Xbox. In addition to regions, Microsoft recently implemented zones. So for instance, you can have redundancy between zones if you have an application and you have to have high availability. The way Azure works, you can have, oops, sorry, I've got to let someone in. Let's see who I can let in. Okay. No, somebody let him in, I guess. I don't see anyone. Okay. So anyway, the way regions work in Azure is regions exist in pairs. And if you have something installed in a region, you can say I want globally redundant data, for instance, and that data will be also duplicated in another region at least 400 miles away. Again, we'll talk about this when we talk about data. So they recently did implement this zone redundancy capability, which is rolling out now. Azure is big. This is a really old slide. I'm sure it's way out of date. Just shows you an idea of how many new Azure customer subscriptions they get per month and how many million SQL databases they have, so forth, how many billion hits to websites run on Azure web apps. Just huge. And the 85% number is probably way low for Fortune 500 companies that use Azure. So let's talk about workloads. These are the common workloads that can be run on Azure, and they're the same workloads that you might run in your own data center. And we don't need to go through the laundry list. It's pretty much everything. It used to be that there were certain applications that were good for the cloud and other application types that weren't good for the cloud, but that's all changed now as the cloud has evolved and as Azure has evolved. This is one of my favorite charts because at one point in my career, I used to run a data center. And as a requirement for running the data center, I used to have to do capacity planning. So what you do with capacity planning is you try to predict over the coming year what capacity you're going to need to run the workloads that the company has to run. So I would do this and I would say, okay, it looks like we're going to need this, but you can't buy hardware in continuous small chunks. You have to buy it in big chunks. So you would over provision. Basically, you would buy more than you actually needed. But life is messy, all right, and the demand curve doesn't always follow that nice, neat, straight line curve. So demand in the company might look something like this over the period of a year. So at the low end here, you can see that what you've done is you've spent a lot of money on capacity that you don't need. But even worse, there may be a point where you have underestimated what you need to actually support the business. When I was audited, when I ran the data center, they said, how do you decide, how much capacity to bring in? And my answer was very straightforward. I said, well, if I spend too much money, I'm going to get yelled at. If I don't have the capacity when the business needs it, I'm going to get fired. So I always overestimate capacity. And again, there's also this part of the curve where you've actually you'd actually be wasting money to have bought all that capacity. Cloud view is great because with the cloud view, you can scale up and scale down. You can buy servers in small quantities and adapt to changing load. So this is really, in a nutshell, this is really the justification for the cloud. Okay. Again, no oversupply, no undersupply, and you can cut back your capacity in times of reduced load. This is one of my favorite charts too, because this one goes back to actually the dawn of Azure. Hang on a second. Okay, just wanted to check. This is a chart which shows the responsibility of various components in a typical stack. And on premises, you know what we've got. We've got networking, we've got storage, servers. There's a virtualization layer in most servers, an operating system that runs on top of that, middleware, runtime, data, and applications. And the whole purpose of this stack, frankly, is to allow the company to run its applications and store its data. So then there's a few terms that you need to understand about Azure: infrastructure as a service, platform as a service, and software as a service. With infrastructure as a service, you can see, and by the way, this is where I bring in the color coding, okay, where everything in red is taken care of by the platform vendor. And that goes all the way up to the operating system layer, but actually part of the operating system layer, excuse me, because you actually have to patch virtual machines in Azure. Now, when it comes to platform as a service, we'll see that you don't actually have to do that, okay? So again, it's getting closer to being a turnkey type of operation where you can just solve your business problems. Don't have to worry about a lot of the plumbing. With platform as a service, that's taken to an extreme where you don't have to worry about any of that lower layer stuff. You just have to run your data, run your applications, and load your data and process and house your data. Of course, with software as a service, you don't have to do pretty much anything. Just use it, right? Software as a service, like service offerings like Office 365. I also include ADP payroll in that category. So that's the difference between the different architectural modes that in cloud services and who's responsible for what. And by the way, if there are any questions, just drop them in the chat. And if I keep rolling on, Roger will interrupt me at a convenient time. Okay. I'm in the wrong screen. That's not good. Okay, moving things to the cloud. There's lots of different ways to move things to the cloud, and Gartner actually has defined a model for application modernization, and there are different categories, each one of which takes different kinds of work to get something up into the cloud. There's rehost, refactor, re-architect, rebuild, replace, and Gartner doesn't have the last one, but I always include remain. Okay, and I'll explain why. All right. Rehost is what you do when you lift and shift servers into Azure. using something like Azure Migrate, you actually do an assessment of the servers you have in your data center, decide which servers you want to move to Azure, group them in waves, and then migrate them up into Azure. And Azure Site Recovery and Azure Migrate can be used to actually do that. Okay, refactor is where you take an application that's on premises and make some minor changes to it to make it more cloud friendly. For instance, let's say you have the typical IaaS.NET application with a SQL Server backend running on premises. It's a very easy move to move that to something that we'll talk about later on called Azure App Services Web Apps. And it's also easy to take a SQL Server running in a virtual machine and move it to a SQL PaaS platform called Azure SQL. And again, we're going to cover that. So refactor is basically moving the application without just moving it as is, but making some cloud-friendly changes to it. The next step is becoming more and more popular these days, and that's re-architecting the application using microservices, maybe converting it to be in containers and so forth. Rebuild is not done too often, but that's basically starting over again with a complete cloud-friendly design. Replace is a really popular choice. In fact, it is possible to migrate Exchange with Office 365, to migrate Exchange into Azure, but no one's really doing that anymore unless there's a really unusual situation. Typically, what folks who have Exchange, which want to take it out of their data center, will do is adopt Office 365, which is a SaaS platform, software as a service. And remain is something that we come across that, like I say, is not in the Gartner model, and that's that there are some applications that you just want to leave alone. Either they've been running fine, and you don't need to get rid of them. In some cases, you may have lost the source code. In one case, I know we came across. So there are some applications that you don't want to touch. So my general migration strategy, and again, this is one that a friend of mine came up with. It's not something that I invented, is that the general migration strategy should be it's software as a service until it isn't, or it's platform as a service until it isn't, or it's infrastructure as a service, or a hybrid approach with any of the above. And what I'm saying here is that SaaS is where you do the least amount of work. The company just uses the application. PaaS is where Microsoft takes a lot of responsibility and you don't have as much. And IaaS is one where you take a larger percentage of the responsibility. Okay, so I just wanted to show you that. This is a slide that I pulled out yesterday from Build because this is an interesting slide that talks about choices. Okay, we talked about IaaS, we talked about PaaS, we've talked about SaaS. It's all about how much control you need over what's going on. Obviously, if you're doing IaaS, you're setting up virtual machines in Azure just like you do in your data center, and you have pretty much complete control over those virtual machines. Some of the PaaS solutions take more of the responsibility, but in turn take more of the limit the amount of physical control that you have. SaaS, like we said, is where you basically just do configuration and use the application. There's a new step, serverless. I don't know if LAS is going to catch on as an acronym, but there are serverless applications in Azure, and we'll get to this. We'll talk about what Azure Functions, which is the serverless product, will be all about. Typically, what we're finding is that people don't want to modernize the application completely by making source changes. So sometimes we take this approach of lifting and shifting something to get it to the cloud quickly using infrastructure as a service, because that takes what they have on premises, moves it to the cloud as quickly as possible. There's a term, time to value, the quickest time to value. And then use tools like Azure Site Recovery or Azure Migrate. Then once you have it in the cloud, you can always make it more cloud friendly by taking advantage of some of the PaaS features that we mentioned before. Okay. These are a couple of charts, and again, it's unfortunate that Gartner hasn't kept these as up to date as I would like. But this is a chart which shows the leaders in the infrastructure as a service business, and as you can see, Amazon is the #1 leader in cloud, but Microsoft is gaining fast on them and has been for some time. And notice, by the way, that there are no real leaders other than potentially Google in that leadership quadrant. You know, Oracle, IBM, they're not really big players. When it comes to PaaS, Gartner has stopped. Let's see, what have I got here? Gartner stopped doing this as of a year ago, but this is a similar chart for platform as a service. And as you can see, there are no references to Microsoft in that leadership quadrant. The only the only leaders here are Salesforce. So I don't know why I included this chart. let's talk about Azure architecture. This is a great diagram. It is not 100% correct. It is impossible to keep this diagram up to date. People have tried. Yesterday, I saw a diagram at PaaS, an architecture diagram which tried to portray every single Azure service, and it looked like a mess. But what this diagram does is it kind of puts the different kinds of Azure services into perspective. You've got your infrastructure services at the bottom with compute, virtual machines, and now containers, several kinds of storage, which you're going to be talking about, all the different networking capabilities that exist in Azure, again, which we'll be talking about. And then you've got all the platform services. And as you can see, there's a ton of services for compute. There's developer services. Again, I won't read the chart. It's just a ton of stuff. And we'll try to talk about some of this or most of this as we go along. So let's talk about managing Azure first. The way you manage Azure, there are a couple of ways to manage it. The entry-level way is to use the Azure portal. Okay. So this is the Azure portal. It is a customizable dashboard. You can change it around. You can pin things to it. You can really make it what you need to manage whatever you're doing in Azure. But this is the kind of information that it gives you. There's also we'll see when we talk about. There's also resource management APIs, groups, templates, and so forth. This is the pricing calculator. The pricing calculator will let you actually spec out what you're going to build in Azure. And you can see that it has categories, and every category has subcategories, and you can actually price out what you're going to do in Azure. Now, I consider the pricing that you get out of this calculator kind of retail pricing. There are discounts and things. In fact, some of the cases you can actually specify a commitment, reserved virtual machine or reserved resource commitments for 1 or 3 years, which will reduce your price. Here's a link to the calculator, excuse me, and also a link to a portal tour. Azure has a marketplace of applications, which is really large, thousands of applications. For instance, a lot of vendors that have firewall products have things in the Azure marketplace so that you can buy. Let's drill down a little bit and talk about compute options in Azure. And the very first thing you want to address in Azure is IaaS virtual machines and virtual machine scale sets. Remember that chart where things, kind of went up and down and up and down? Well, what you can do in Azure is you can actually auto scale resources, and that holds for virtual machines. You can specify something called a scale set, which is essentially a group of like virtual machines that can be added and deleted from a workload as the load increases or decreases. So you've got virtual machines and scale sets, support for Windows and Linux virtual machines. In fact, Linux is actually now more popular in Azure than Windows. There are more Linux virtual machines running in Azure than there are Windows virtual machines. So you've got auto scaling. if you have multiple virtual machines performing a function, you can have a load balancer in front of those virtual machines, so you can actually get scale that way. In fact, unlike some of the other vendors, the load balancer in Azure for external access is free. And we'll talk about load balancing when we talk about networking. As I said earlier, Microsoft does not update or patch the virtual machines. They do pretty much all the rest of the management, but not that. And you're responsible. And there are virtual machine extensions for startup customization. There are automated ways to create virtual machines. There's something called Azure Resource Manager, which we'll talk a bit about later, for customizing the architecture of the virtual machine. And there's something called PowerShell Desired State Configuration for customizing the inside of the virtual machine, for setting various Windows features, installing software, and so forth. You can get, one of the disadvantages of working with things in Azure is you can't just walk up to the console and start typing away, but you can remote desktop or secure shell if it's Linux into a virtual machine. However, since public IPs are dangerous, folks have resorted to setting up things called jump boxes, which were virtual machines that did have a public IP, and they were tightly secured so that they could only be accessed, let's say, for instance, from a particular IP address or particular location. Microsoft has recently implemented something called Bastion Host, which I like to call Jump Box as a Service. So it's a PaaS service in Azure that provides the same functionality as having a jump box. The nice thing about that is that you don't have to worry about setting up the jump box. It's just something that you use in Azure because it's a PaaS service. And there's all kinds of tooling to support in this portal to support that. Microsoft has tools. We'll talk about the tools later on if we have time. But there's the portal, obviously. There's Visual Studio for developers, or Eclipse if you're a Macintosh developer, software development kits and other tools. There's a virtual machine gallery, not only of the virtual machines that Azure makes available to you, but also a huge gallery of contributed virtual machines called the VM Depot, which you can actually find virtual machines that other folks or other companies have put up there. Those links, again, when you get the deck, I would encourage you to take a look at those links. These are some of the most important links that I know of. The sizes for Windows virtual machines and the sizes for Linux virtual machines are included at those links. Hybrid use benefits I included here because you can actually save a lot of money if you have Windows Server on premises or SQL Server on premises. You can actually use the license that you've already paid for in Azure, so that does reduces the pricing. If you just buy a virtual machine that has, let's say, SQL Server running in it, you're paying for the operating system and you're paying for the SQL Server as well. But if you already have those things in your data center and you've paid for them, could be a big savings. There's reserved instances, which we'll talk about later. And reserved instances are basically a way to save some money as well. If you're willing to make a 1-year or a 3-year commitment, you can save a large percentage of the price on a virtual machine. And that can be something like 40, 50, 60% of the cost. So it's a significant savings. Recently, Microsoft announced something called burstable virtual machines. These are virtual machines that are really cheap, but that Microsoft could preempt if they need the virtual machine for some other purpose. So yes, they're cheap. I would never use these in production. I would only use them, in a development environment. Speaking of virtual machines, here's the limit. This is the summary from that link that talks about the sizes for Windows virtual machines. As you can see, there are a whole bunch of categories based upon what you're going to do with the virtual machine. And there are all kinds of sizes of virtual machines. And again, this chart is only a real high-level summary. There's a lot of virtual machines. One of the things, for instance, that when you do a migration assessment to migrate things to Azure, they will help you size the virtual machines you have on premises to the right size virtual machine running in Azure. Because a lot of data center hardware, virtual machines, and so forth are typically over-provisioned. It's not uncommon to have a server, even a whole physical server, running at 20 or 30% of its capacity. So if you want to have Azure, if you want to have Azure be provisioned more closely to what you actually need, there's tooling to let you do that. I also mentioned I get a big kick out of the Cray supercomputer. Azure does have one. It is in preview. I don't know too many folks who really need that, but it's out there. Okay, the first thing I want to talk about is that way I mentioned to take a web application that you have running in your data center and just move it quickly up into Azure. There's something called App Services, which has a whole bunch of subcategories of tooling, and the main way to do this is to use App Services, something called a web app. And a web app is basically where Microsoft provides a whole web farm for you under the covers, running SQL, running IaaS, and it supports a backend database like Azure SQL or MySQL, and it also supports limited virtual network connectivity, which we'll talk about when we talk about networking later on, to talk about tying things back to the data center. Now, one thing to be cautious with though is app service is a shared pool of servers. What that means is that although you're isolated from other users are actually using that same pool of servers. So that you could be subject to the noisy neighbor problem. So you do have to be careful. And if you cannot live with that, there's something called the app service environment, which is basically the same thing, but as a dedicated pool that you alone own. So there you won't have any noisy neighbors. So when you need a very high scale application, you can start off with app service. And if that's not good enough or not performant enough, you can always upgrade to Azure Service Environment. Now, App Service Environment is not cheap. The base product in App Service Environment can cost you up to $500 a month just before you even start adding applications to it. So you do have to be a little bit careful. Okay. So it's a dedicated pool. It's for apps that need higher scale. And it can, unlike the app service, and the app service web apps have limited network connectivity. App service environment, because it's a dedicated environment, can be in a regional virtual network. Okay. And of course, it also supports Windows and Linux applications. So you can have, you can have a pool for Windows, you can have a pool for Linux. If in your application on premises you have foreground processing and background processing, there's a solution for that as well. Now, so let's say you have an idea to build the next YouTube. So it's going to be a great solution, but you don't want to have to go out and buy a whole bunch of servers. You're going to use Azure and grow as you need it. So you have a web front end that lets people upload a video, and then you have a back end that would encode the video and post it to some kind of database. So the way to implement that would be to use an app service web app in the front end and a web job, which we'll talk about. So again, the web app is the quickest way, like I said, is the quickest way to migrate a net application with a back-end relational database to Azure. Okay, we've talked about this. As you'll see when you look at the pricing calculator, there are different tiers of pricing, each with different capabilities. And in the case of app services, there's actually a free tier, which is used by, can be used by startup companies. The shared mode we talked about, and then there are, again, additional tiers. Just like there's a virtual machine gallery, there's also a web app gallery with templates, individual built web apps for specific purposes like WordPress and Drupal and other usage. And of course, App Services, Web Apps also provides load balancing and auto scaling. And again, once again, the load balancing comes free. The load balancer comes free. And the auto scaling can be based upon, performance counters and other metrics that you have that you can measure. Okay. Azure Functions is somewhat newer. Azure, you'll hear the term serverless computing. And serverless computing are not serverless. There is a server somewhere. But the point they're making here is that you're only paying for the compute time that you use. For all the other, most of the other services in Azure, once you deploy a website or once you deploy a database, the meter starts running and you start paying for that. Serverless computing is where you just want to respond to some kind of event, do some processing, and go away. Okay, so it's really good for that kind of application. It's not great for applications that have heavy workloads or that need to be up all the time. Because the one disadvantage of serverless applications, as you might suspect, is that there's a startup time which can affect response time. So you do have to be a little bit careful and use this for things like back-end processing. There's a lot of other compute options. There's logic apps. If you're familiar at all in the data center world, if you're familiar with something called BizTalk, where you could actually drag and drop an application on a grid and connect the pieces together, and lo and behold, you have an application. That's what logic apps is all about. So basically, like I say, you basically connect components together graphically, and that the code is created behind the scenes to do that. There's API apps and API management if you're in the business of internally or even externally creating APIs that are going to be used by other folks. And there's capabilities to publish APIs, to secure them, to manage them, and so forth. Again, you could be developing these APIs for other projects in your own company, or you could be developing them for sale to other being used by other companies. There's a whole bunch of components in Azure to support building mobile applications. Basically, Azure supports the back end. Obviously, Microsoft has a lot of front-end capabilities, but for Azure itself, there's back-end solutions to power mobile apps, all the different the different kinds of phones out there and tablets out there, and so forth. So there's that. There's a whole media pipeline which has a workflow for media creation, ingestion, encoding, management, and distribution of media, video. And there's a job scheduler, which is kind of like the Windows scheduler, where you can schedule tasks to be run at a particular point in time. And you can do that through a REST API. There's a .NET SDK for that. There's PowerShell. You can also do it through the portal. So there's just some of the other compute options. Again, nowadays there's too many compute options to go through all of them in detail. This is a great chart that actually just came out that I grabbed yesterday from one of the presentations at Build. And this is how do you choose? There's so many options. And I won't take you through this whole chart, but it does give you kind of a feel for, if you're migrating a newer app, or are you migrating or building a new application? If you're migrating, are you going to do it lift and shift? Otherwise, you can follow the chart through the rest of the steps. Okay? And down at the bottom and on the right-hand side are all the destinations that you might end up at. And we've talked about a couple of these, right? We've talked about virtual machines, app services. We've talked about containers. The Azure Kubernetes service is a container orchestrator. And we've talked about app services there twice, okay? We mentioned Azure Batch, Azure Functions, container instances, and so forth. So again, this is a pretty good chart. That's why I grabbed it and put it in the deck. I should mention that this is a deck that I've been maintaining from the beginning of Azure back in, 2007 is when I actually tripped on Azure internally at Microsoft before it even had a name, Azure. Containers are getting to be more and more important with Azure and in the cloud. And a lot of people have, if you haven't come across containers yet, you will. I call containers the third generation of virtualization. Remember, initially we had physical hardware, and that physical hardware often was brought in to do a particular application. And that's where you had things like a server that would only run at 20% of its utilization or less. And companies decided they wanted to get more use out of that hardware. So we moved to virtualization, which was a way of virtualizing the hardware, again, to do more with less. Well, the third generation of operating system virtualization is containers, and that actually lets you do more with less. Now, if you look at a container, all right, oops, sorry. If you look at a container, with virtualization with VM, what you actually do is you actually create a hardware virtualization layer, and then each virtual machine has an operating system in it, and the application runs in that operating system. With containers, they virtualize the operating system itself, so there's really only one operating system in the host virtual machine. And then the containers sit on top of that, and they are cleverly architected so that when they access the kernel, they're actually going through something else, another layer, so that they don't actually do direct access. When they're accessing files, they go through a special file system. So they basically created an environment that protects the underlying operating system from the container, from what's running in the containers. And Azure has a couple of services related to containers. There's Azure Container Instances for individual containers, but the big one that everybody should be taking a look at, in my view, is Azure Kubernetes Service. And Azure Kubernetes Service supports Kubernetes, which is a container orchestrator. So you can build an application consisting of multiple containers. Folks use Docker to build those containers and orchestrate them together. You could have an application, for instance, that can't fail. So let's say you have an application doing a computation and it could fail. Let's say it's counting up, just to take a trivial case. Let's say it's counting. There could be more than one replica of that container running, so that if a container should fail, the other container could pick up right where it left off while they're recreating that container. So again, it goes towards high availability. Recently, Microsoft just also came out with container support in Windows Server itself on premises. So again, you could have an application that runs in containers. You could have an application that runs in containers across clouds. You could even have an application that runs in containers across the clouds and the data center. So it's pretty flexible, pretty convenient. Okay. Again, I won't go. I'm not going to read the whole chart. It'll be there for you. Container instances, you get billed by the second, so it's like a serverless service. It supports a lot of different capabilities. I know we don't have a lot of time tonight, so I'm not going to go into it. But this is a description of this is what Kubernetes looks like. Again, you can see the different color coding. We've got we've got nodes, which are virtual machines in Azure, and then every node has multiple pods, and the pods run the containers. Okay. And if we look at, for instance, the green pod in the upper container, we can see that they're also running in replicas in other containers. So this is what Kubernetes is all about. The Kubernetes service is a PaaS type processing, a PaaS type capability, and it is managed by Kubernetes. And you don't actually pay for the master. So it's a master and a bunch of nodes, and you don't actually pay for the master. That's provided by Microsoft as a service. So supporting incoming requests as APIs, scheduling nodes, scheduling pods, and so forth is all supported by the master, and it is an as a service type capability. Let's talk about storage. Okay. Are there any questions so far before we go on? Okay, I'll keep rolling. Azure Storage is highly available and massively scalable. Now, the nice thing about Azure, there's a couple of nice things about Azure Storage. First of all, you pay only for what you use. So it is supported. You might say that eventually I'm going to need 10 gigabytes of storage, but I only need right now. I'm only using a couple of hundred megabytes. You're only paying for that. Okay. You can access Azure Storage remotely as well as in Azure. It has a REST API. There are client libraries and tools, and it will auto scale to meet massive volume and throughput. Now, when I say massive volume, I'm talking about like petabytes of data. So you can scale from the very small to the very large. And you can access that storage from anywhere, either internal to Microsoft Azure or using that REST interface through the internet from almost anywhere. Important concept that I mentioned earlier is the ability to have high availability. And that's through a concept called storage redundancy. When you create storage in Azure, locally, there are actually 3 copies of that data in a data center, and that's called locally redundant storage. So if something should happen to one of those copies of storage, they can recreate it from the other 2 copies. So that gives you, very high availability. If that's not enough, you can actually have another 3 copies made in another data center at least 400 miles away from the primary data center. That's called geo-redundant storage. I mentioned earlier that Microsoft has also implemented an intermediate solution, which is to have another 3 copies in another Azure data center in the same region, but physically separate from the data center, from your primary data center. Okay. Additionally, for geo-redundant storage, you can actually have read access geo-redundant storage. So for instance, you could be having your data stored in that other data center and do reporting and other non-transactional access things against that data. Okay. Azure Storage supports encryption at rest as well as in transit. It's currently a 5 petabyte limit per storage account. In Azure, you create storage in things called storage accounts. Okay, and they've recently increased that to up to 5 petabytes, so that's pretty large. You can have 250 storage accounts per region per subscription, and that was an issue when the limit to storage for a storage account was 100 megabytes, but now it's 250. Now it's 5 petabytes. The link at the bottom is a very important document that you should all have. All the limitations and all the services in all of Azure are defined in that document. Okay, so if you ever have any questions like how many file shares can I have in Azure Storage, which we're going to talk about, or how many, all the limits are there. Storage comes in different types. Okay, there's tables, which is actually think about it like a NoSQL database. Group of entities, name value. Each entity has name value pairs, but it's not really a table in the relational sense because every row can be different and have a different structure. But the nice thing about table storage is it's extremely scalable. It can scale out to billions of entries. Just remember that it's not relational data. Okay, so you can't process against it with something like SQL Server, for instance. Queues are used for simple message queuing. Let's say that application that I mentioned earlier, where you have the next YouTube, and you're going to let people upload videos, and then you're going to encode them and post them and do things with them. You could use a message queue to communicate between the front end and the back end. So Azure queues are non-transactional, but you can read them. They will guarantee that they will be read at least once. Because what you do is you read a record from the queue, you delete it to remove the message when you're through processing it. If for some reason the job cancels or crashes before you get to the end, it stays in the queue and is picked up by someone else. So it is idempotent. In other words, it will always be picked up by someone. No guarantee that it might not be picked up twice, so you do have to be careful. There is an alternative, which we'll talk about later, called Service Bus, which provides a much more sophisticated queuing capability that can be used as an alternative. But the big brother in Azure Storage is definitely blob storage. Blob storage is large binary storage created in containers. It kind of looks like a directory structure, but and you can mimic a directory structure by just putting slashes in the names of the containers. It is used to store large binary storage. It's used to store things like videos and large text documents and so forth. Okay. There is a contact delivery network, which we can mention when we talk about networking, which lets you cache blobs out to be near the consumers of those blobs. So there's blob storage in Azure, but there's an even larger community of locations outside of Azure that are content delivery network locations. And like I said, it is partitioned by blob name. Two kinds of blobs. There's block blobs and page blobs. Block blobs are used for things that you're going to process sequentially. Page blobs are used for data that you're going to process randomly. And there are two kinds of categories. There's the basic storage, which is essentially rotating disk storage implemented in an Azure data center. And there's premium storage, which is implemented through solid state devices. Continuing on with disks, page blobs are used to implement disks, virtual hard drives in Azure. So these are durable disks. Again, you're going to migrate an application to the cloud. The operating system has a disk, which is implemented in the data center, probably by a virtual hard drive. These disks are VHDs. You can store them. You can have virtual hard drives in Azure. There's a 32-bit maximum disk size. One of the considerations when migrating a server to Azure is if you have any situations where the server can't be moved to Azure without making any changes to it. That's one of the things that can sometimes happen. Okay. And the number of disks that you can have varies depending upon the virtual machine size. Some of those smaller virtual machines that I showed you a little while ago can only have a few VHDs attached to them, but some of them can have very large VHDs, very large numbers. Okay. Used to have to create a storage account for your VHDs. Now Microsoft has something called a managed disk, where you don't need a storage account. There's really a storage account under the covers that Microsoft has created, but you don't have to worry about that. Okay. Azure Files is a great solution if you have a file server that you want to move into Azure. File servers use a concept called SMB, and they're accessed essentially by a drive letter. Well, this is the same thing in Azure. Okay, so you can have up to 100 terabytes files, up to 100 terabyte file server in Azure, and you can have all that availability and durability and scalability given to you because you're running it in Azure. There's also a service called the File Sync service, where you can actually have a file server in your data center that is where changes are synchronized up into Azure, and so that you can actually have the bulk of your data in Azure, but the most frequently accessed data located on premises. Okay. And it supports two interfaces. It supports server message block, SMB, which is the drive letter mapped drive approach that we talked about, plus a REST interface. REST is, in case you haven't come across that term, is representational state transfer. It's a way of basically, hang on a second. It's a way of actually accessing resources via a URL. Okay. So again, there's Azure Files for file serving type applications. Storage classes, there are different categories of storage. I mentioned there's standard storage, and then there's premium storage. There's also storage tiers. There's hot storage, cool storage, and also archive storage. So what hot storage is the typical storage that you want to have fast access to. Cool storage is slightly slower to access and cheaper. And then there's archive storage, and I call archive storage the storage for write once, read almost never storage. Things like police videos, police dash cam videos, things like data that you need to keep around for 7 years for regulatory requirements and so forth. Okay. And there's actually policy-based storage account tier migration, which is pretty sharp. For instance, you could have data in hot storage, and then after a period of time, migrate that to cool storage, and then after a longer period of time, migrate that to archive storage. There's a really good tool that's recently been integrated into the portal itself, but you can also get it as a standalone, as a standalone tool. And that is the Azure Storage Explorer, which will let you browse just like the file Explorer in Windows, let you browse through your resources in Azure. If you have a large amount of data to move into Azure, you may not want to take the time to push all that data through an internet connection. Internet connections typically are not that high performance. So if you have a large amount of data, Microsoft has several solutions for that. You can put your data on hard drives and send it to Azure, and they'll load it into blob storage for you. In fact, when you create this into the portal, they'll actually let you print a FedEx shipping label for your data. It's for huge amounts of data. You can copy disk to the data. When it comes to taking the data out of Azure, you can send them the disks, and they'll put the data on it. The data is encrypted with BitLocker, so only you have the key. So although Microsoft can load the data into Azure, they can't see what the data is. Now, that's what Microsoft started with. More recently, they've created something called Azure Data Box, and these are actually physical hardware appliances where you can transfer up to a petabyte of data. Oops, I guess I didn't include the slide, but there's a small box which looks like a desktop PC console, and then there's one that's on the larger end, which looks like something that you might see someone pushing around at Home Depot. It's like a big cart. So again, I guess I dropped the slide. I apologize. Talk about database in Azure. Azure databases are database as a service or platform as a service, and Azure supports a lot of different kinds of databases. There's three kind of versions related to SQL Server, and there are some other database types out there. Now, Azure SQL Database is that database type that I mentioned where I said you've got a SQL Server in a virtual machine in your data center, and you want to migrate it up into Azure. You could migrate it as a virtual machine, or you could use the platform as a service version of SQL Server that Microsoft has. If you've been responsible for the care and feeding of SQL Server, you know that there's a lot of administrative tasks associated with SQL Server. There's, file groups and, data management groups and things that you have to actually manage. And that's why DBAs spend a lot of time, in the care and feeding of SQL Server databases. With Azure SQL Database, most of that is taken care of by Microsoft. The only downside of SQL Database is that SQL Database only supports about 90% of the capabilities in full SQL Server. For instance, things like analysis services are not supported, and folks will find other things that might not be supported. In general, though, that's the first thing you should look at when you're thinking about moving a SQL Server database into Azure. If you need more capability, Microsoft has provided something called SQL Managed Instance, which has pretty close to 100% of the capabilities of full SQL Server. Again, there still may be a few things a few gotchas that you have to worry about. For a solution for data warehousing, Microsoft has something that used to be called SQL Data Warehouse. Now they've renamed it as SQL Synapse, but basically it's for building data warehouses. So with SQL Server, you can scale up and scale down SQL Server and SQL Database. SQL Data Warehouse lets you scale up your compute and your storage of the database separately. So it's really useful, for instance, for having different performance requirements on the front end and the back end of the SQL Server. Cosmos DB is pretty cool, and again, we don't have time to go into it in detail, but Cosmos DB is the newest database that Microsoft has come out with. It is a global distributed database. If you're going to have a database that spans different regions of the world, where data needs to be synchronized between the two, the Cosmos DB is definitely something that you should take a look at. Now, those are all Microsoft database products. Azure also supports some open source database projects like MySQL, PostgreSQL, and MariaDB. So if you're moving an application from a Linux environment, say for instance, that uses MySQL, that's supported in Azure and can be used. Mentioned earlier, obviously you can move SQL Server into Azure just as is and run it on a virtual machine. In fact, you can run lots of databases. You're not really limited in terms of what you can run on a virtual machine in Azure. It's just as if you had it in your own data center.
Hey, Bill, we're hearing
Yes.
a beeping sound in the background.
Really? I don't hear it.
It seems to get closer
Wait a
when
minute,
you lean into your mic.
Oh. Yes, you are, and I just
There
realized I had set an alarm clock so that I would be sure and give you guys a break in the middle. So as soon as we finish database, we'll take a 10-minute break. Okay? That okay?
Sure, sounds good.
Okay. 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 It's funny. All right. So anyway, to move databases into Azure, there are various tools, and these are mostly tools for moving SQL Server databases. There are some tools will actually, let you input other kinds of databases, like for instance, IBM DB2 and Oracle and so forth. But there's a data migration assistant. There's a data migration service. You can migrate a database into Azure using replication. So for instance, if you have a SQL Server database on premises, you can have it replicate to a copy of the SQL Server database that you have in Azure just through normal SQL Server replication. You can actually take a backup of a SQL Server database in a backpack and restore it in Azure, and so forth. So there's some pretty good capabilities. In fact, there's some overlap between the data migration assistant and the data migration service. Okay, so we talked a little bit about this. Like I say, it gives you about 90%, the SQL database gives you about 90% SQL Server compatibility, support for existing APIs and tools, just as with storage, where when you create some storage in Azure, it's stored in triplicate. Same thing is true for SQL database. So you create a database in Azure, there are 2 other copies. If the first copy should get corrupted, they can reconstruct it from the other 2. Now, don't be lulled into a false sense of security. If you make a change that hurts the database, it's going to hurt all 3 copies. So that's no excuse for not backing up your database, and having a backup and failback capability. But it does understand the Transact Data Services protocol, and it does look like SQL Server to most applications and clients. For instance, you use the Microsoft tooling to actually access it just like you do with SQL Server. One of the nice thing, and again, if you remember your SQL Server, you know that there are logical and physical management data management views in SQL Server. With SQL database, you don't have the physical management views anymore. You just have the logical ones. So you just have control over indexes and query plans, but you don't have control over things like where files are placed and so forth. That's all taken care of for you. Okay, again, we're continuing primary plus 2 replicas. There's, again, multiple tiers, again, with different pricing. Pricing is based on something called a database throughput unit, which is a fairly complex combination of CPU, storage, IOPS, and so forth. And there's actually a calculator out there for figuring out, estimating what you're going to need for a particular application. And there's also a virtual core-based. There's actually a virtual core-based pricing if you just want to duplicate exactly what you have on premises. You don't want it right-sized like you would get from something like the DTU calculator. SQL databases are limited in size to 4 terabytes, which is not terrible, but there are some database, SQL Server databases that are larger than that, so that could be an issue. Okay. Microsoft provides a service level agreement, a service level of 99.95, which is pretty reliable. And SQL Database has automated backup and self-service recovery capabilities built into the database. Now, Azure does have backup as a standalone offering, and they have disaster recovery too as a standalone offering, which we'll talk about. But this is built into the database itself. You can have active geo-replication of the databases. I mentioned 3 copies in a data center, 3 copies in another data center at least 400 miles away. The same holds for a SQL database. Okay, geo-redundant read-only replicas. If you have a whole bunch of SQL databases and you want them to share resources to be cost-effective, there's something called elastic scale, where you can actually, have a pool of databases, kind of like a logical server. Okay. And there's SQL Data Sync, which is a really interesting capability to synchronize multiple SQL databases and SQL Server databases, including ones in Azure and in your own data center. So, for instance, you could theoretically have a database on premises synchronizing up to a SQL database service in Azure. You could also have multiple SQL servers and multiple SQL databases synchronized with each other. Mentioned SQL Managed Instance, that's for lift and shift. Again, much more SQL compatibility. These are some of the features that SQL Database doesn't have that SQL Managed Instance does have. The common language runtime, the ability to write SQL Server stored procedures in a language like C#, is supported in SQL Server, but not in SQL Database, but it is supported in Managed Instance. The SQL Server agent, which I mentioned earlier, is not part of SQL Database, but again is provided in this offering. Cross-database queries are also not supported in SQL Database, but they are in Managed Instance. And the ability to have private IP addresses is useful. There's also, I mentioned earlier, there is a database migration service, and that database migration service can be used to migrate a SQL Server database to SQL Managed Instance. It is probably, the least painful way to take a database that's running on premises and just get it up into Azure. I mentioned Synapse. Synapse was the SQL Data Warehouse product for analytical workloads. Stores large volumes of data. They've taken SQL Server and separated the compute and the storage parts so that they can be stored they can be scaled rather independently. But it's not for online transaction processing. It is literally for data warehouse type applications. Excuse me. Mentioned Cosmos DB. Again, I don't want to drill into this, but there's some information here related to how it works and why it's so globally distributed. Okay, let's take a 10-minute break. Let's see. It's pardon? Do you have questions? Was there a question?
Yeah, hi Bill, this is Vijay.
Yeah.
I think I just asked a question related to.
I can't hear you. Your voice is all distorted there.
Okay, I have posted my question in chat window.
Oh, okay. I'm sorry. Is there a question? It's hard for me. There must be something.
Yeah, there might be a problem with my maybe microphone.
You know what? Could you post your question in the chat?
Yeah, I did that.
Oh, you did? Okay, let me look at the chat. Okay. Yes, there is. Cosmos DB. The question is there any offering in Azure which can support both relational and document database services at the same time? Absolutely, there is. Cosmos DB. Cosmos DB has a document mode and it also has a SQL mode. So you could support both kinds. Again, it's really good for that. They consider it a document DB, but it can even support the storage architectures used by some of those other open source databases that I mentioned a little while ago. Let's see. Okay. Any more questions?
Yeah, I had posted a question. My question is, with the SQL services in Azure, a lot of our applications that we use in my company are from vendors, and they say your requirement's a Windows server and a SQL server. Does the vendor software have to support Azure SQL database services from a technical level, or can if it needs SQL Server, you can use Azure SQL Server?
Yeah, that's a good question. All right. The answer is it all depends. Okay. At any rate, they'll have to agree to let you do that, right? They'll have to agree to support their product when it's talking to other than native SQL Server. That said, if it's not using any of the special features, the 2 or 4% of the features that aren't supported in SQL database, or maybe not, even maybe some features that aren't supported in SQL managed instance, then that could be an issue. So really, most vendors will actually give you an answer and say, yeah, we support our product running in Azure, or we don't.
I see. So it's more geared for in-house development then.
What's more?
Like the SQL services.
No, there's a large number of vendors who support support the Azure SQL database.
Okay.
Really, you should talk to the vendor and say, we're thinking about moving this to Azure. Chances are, they will say, okay, no, you got to run SQL Server in a virtual machine in Azure.
Mm-hmm.
But some of them will actually say, we've tested Azure SQL database, and we support that. Obviously, there's probably a different installation procedure for their application, right? So,
yep.
Okay.
There's different flavors of Azure SQL. So depending upon, I was saying that Azure SQL has different flavors, but the managed instances, that's more like what you think of as on-prem SQL Server or IaaS SQL Server. But you just kind of have to do a assessment of what features you're using in SQL, and then go from there. But things like file streams and file tables aren't supported, for instance, in Azure SQL.
But are they support? I think they might be supported in managed instance, right? So you have to look at.
It wasn't last year. I haven't checked it out recently.
Mm-hmm. Okay. Yeah, that's good. You still have to be careful of that 2%, even with SQL managed instance. There are still a few things that aren't fully supported. But again, you can run SQL Server in a virtual machine. You can run, you can have a pool of SQL servers. There's a lot of things you can do like you do on premises.
Run it in a container on Linux.
Yeah. As a matter of fact, that's supported as well. In fact, there was a whole, at Ignite, 4 or 5 months ago, there was a whole session on running SQL Server in an Azure container.
Yep. Bill just had a session on it also. I've watched one session. So
good.
All that stuff's out there. Everybody is interested.
Yeah. Pluralsight. There's actually I'm a big fan of Pluralsight. I use Pluralsight a lot for training, and there's a unit on SQL Server in a container in Pluralsight as well. If any of you guys have Pluralsight, it's very useful. Okay, let's come back at 1:30. I'll pause the recording, get some coffee, take a drink, and then we'll come back. Okay. See if I can do this correctly. Okay, I don't see a pause recording like there is with Zoom, so I'm just going to let the recording run, okay? Okay, let's go on, get started. I shut off the video in case some of the audio issues are improved by less bandwidth. So, all right, let's talk about networking. Next topic.
All right.
Okay. I guess, is everybody okay? All right, talk about networking. Okay. Azure has a lot of services, and we're only going to talk about a few of them in detail. But this chart shows all the different services related to networking that Azure supports. When it comes to communicating from outside of Azure to inside of Azure, there are two kinds of virtual private networks. There's the point-to-site virtual private network, which is something I'm sure everybody's familiar with, where you're let's say you're at home on your computer and you need to communicate with applications and data in your data center. So the company provides a VPN capability, and you can actually get an encrypted tunnel into the data center. The same thing exists for Azure, but more importantly, I think the ability to create a site-to-site virtual private network between resources in Azure and resources that you have running in your data center. Okay, so you might have an application running in Azure that needs to access data in a SQL Server database that's still located in your data center, for instance. And the site-to-site virtual private network, is a tool to use to actually implement that kind of architecture. So it's a true virtual private network. Again, virtual networks in Azure are actually software-defined networks. They are true networks in the sense that you build networks in your data center, except that they're built in Azure. A virtual private network, point-to-site or site-to-site, you can have multiple virtual networks in Azure, and you can also peer those virtual networks together. Now, what do I mean by peering? In an Azure virtual network, you create a virtual network, you can create subnets in that network, but resources in the virtual network can usually talk to each other, but they cannot be accessed from outside of the virtual network unless you start doing things like exposing public IPs on resources in the network. So you might have a virtual private network for a particular department or company or division, and you might put your resources in that virtual network, but you would not necessarily want anybody coming in from outside to be able to access that information. There are cases where you might want two virtual networks to share resources, and that's where peering comes in. So you can actually tie those virtual networks together such that resources in one virtual network can access resources in another virtual network. So you have the ability to create a virtual network with an IP address space. You can create subnets. There's obviously you need some kind of infrastructure on premises to have a virtual private network, either hardware or software. Azure supports a selection of VPN devices from various vendors. The nice thing about Azure virtual networks is, especially in point-to-site, is that there's no special access agent required. Okay, so with VNet, if you look at the architecture of Azure, and again, we haven't spent a lot of time looking on the regional architecture itself, but essentially a region contains the resources in a particular geo, and you could have two virtual networks in the same region, or even across two different regions that need to communicate with peering, and that gives you a low latency, high bandwidth connection between those two. The interesting thing about region to region is that communication between the two regions is going to happen over Microsoft's private backbone network, as opposed to the public internet. That's not true of other vendors. Okay. So there are firewalls that you can use in Azure for networking. There's also network appliances from third parties like Barracuda, Checkpoint, Palo Alto, and so forth that you can use. You can find those in the Azure Marketplace, as well as an Azure firewall, which is a pretty good firewall. It doesn't have some of the features of the third-party products. There's also a VPN gateway, which will let you create a gateway between what you have running in Azure and your data center. So essentially, it's like having your on-premises networks be be part of your virtual network complex. Okay. This is an example. I actually did a webcast on building a rational Microsoft Azure network architecture. We used, and Microsoft, by the way, promotes this as this kind of architecture as a hub and spoke architecture, where you might have spokes for the different environments like development, quality assurance, production, and so forth. And common resources are actually existing in a central hub. Then what you do is you peer those environments together with the central hub virtual network so that those common resources can be accessed from each of those environments. So virtual networks, you have virtual networks and subnets. You have network security groups, which are like little mini firewalls. You definitely need, something like a firewall or a network security group protecting your resources in Azure. Okay. There's just some, some of the examples of things that might exist in that separate hub, that central hub, which is core infrastructure. Again, you could put your jump boxes in there. You could put firewalls in there that do firewalling for all the different environments. Now, when I did this webcast, which was quite a while ago, and this is all, by the way, this is all in my blog, Cloudy in Nashville. But when I created this at the time, we were using virtual networks for environments. So this was a single subscription architecture with multiple virtual networks. More recently, Microsoft has changed the pricing for development in Azure, and you can actually save a lot of money on a subscription if that subscription is only using development resources. So instead of a hub and spoke network architecture with virtual networks, we've moved to a hub and spoke architecture with subscriptions, where each subscription would be would hold the resources for a separate environment. Excuse me. Okay. So again, this is just an example of network design in Azure. Mention the public load balancer. Again, you can have a public load balancer as soon as you have multiple things in an availability set in Azure, like multiple virtual machines. You get a load balancer in the front end, and that load balancer is free. Okay. Now, that's also true, by the way, with some of the PaaS services like web apps. You get a free load balancer there as well. You can have a load balancer between the tiers in a multi-tier architecture. For instance, let's say that you have, a web farm front end, and then you have an application tier and a data tier. If it's not a one-to-one relationship, you could actually have a load balancer in the middle of that. Now, those load balancers are not free. There's a product service in Azure called an application gateway, which has it's similar to some of the VPN gateways. Again, there's more, a lot of information. HTTP routing in Azure is normally, when you're sending requests to a pool of machines, you don't have a guarantee that the next request coming from a particular client will go to the same virtual machine, but you can specify affinity so that you can actually have, force that to happen. Mentioned third-party appliances in the Azure firewall. Azure has a firewall, and it's a high availability firewall as a service, so it's redundant. It's a PaaS type product, so you don't have to worry about high availability or scalability for that matter. Microsoft takes care of all of that. It'll do some of those firewalling things that you're familiar with, like logging and enforcing access policies and so forth. It is not as full functioned as some of those third-party products that I mentioned earlier. Traffic Manager is kind of an interesting product. I mentioned the load balancer, and the load balancer runs, let's see if I can get this. Okay. The load balancer runs in an Azure data center in front of an availability set of virtual machines or a web app with its load balancing as part of the service. If you have resources in multiple data centers or data centers and on premises, you can use something called Traffic Manager to load balance requests coming in. One of the nice things about Traffic Manager is that Traffic Manager will route requests to the nearest location, the nearest service endpoint. And one of those endpoints can be in your data center. Okay. It has a lot of different capabilities, which we won't go into in detail, but it is not the same as having a content delivery network. All right. This used to be the only way to do that, but more recently, Microsoft has come out with something new, which we'll talk about in a bit, called Azure Front Door. One of the interesting features about Traffic Manager is that it is DNS based. So, what they will do is they will take a request, and using DNS, they will route it to the closest resource. The problem with DNS is that sometimes DNS changes take a while to come into effect. So Front Door is something that is not based on DNS. It's really a PaaS service in Azure, and it will route requests again to the closest consumer of that service. But it's a little, it can give you higher performance, slightly different, different characteristics. ExpressRoute is really interesting. A lot of companies have been slow to adopt the cloud because of security considerations, and it's really a false hesitation. I maintain that Microsoft has more security and more capabilities to provide security than any company could afford to have in their own data center. But be that as it may, some people are very, very reticent to actually pass their data over things like the open internet. So what ExpressRoute is a direct connection to Azure. It does not use the internet. What that means is you have to have some kind of hardware installed in your data center or at a special provider that has a direct connection to Azure that's not internet related. Okay, and you can get that from carriers like AT&T. You can get that from some of the other vendors out there. It connects you directly from your wide area network to Azure. Multi-point line services is what they call what AT&T calls their product. MetroNet is another one. There are carriers and exchange providers like AT&T, Verizon, Equinix. Equinix is the big one. Equinix started out as a hosting company, but they have now, they've now graduated to being a full direct connect to Azure provider. And one of the things about a couple of nice features about ExpressRoute, if you've ever measured performance over the internet, you know that last mile is kind of a killer. That's not terribly high bandwidth when you have a direct connection to the internet. But with ExpressRoute, because it's using higher speed capabilities, you could actually get speeds up to 500 gigabytes per second, which is pretty, you won't get any internet access capability with that kind of performance. Also, I personally measured 3 to 5 millisecond latency over an ExpressRoute circuit to Azure. Again, you're not going to get that kind of latency from a direct internet connection. And the security, obviously the security of not going over the internet is very attractive to some folks. There's a VPN connection capability. You can do Office 365 over ExpressRoute. However, most folks usually you do ExpressRoute over the internet. There's a built-in redundancy and backup capability that lets you use a VPN to back up ExpressRoute. One of the most important features, though, is the cost. ExpressRoute is not cheap. Okay? The other problem with ExpressRoute sometimes is that it takes quite a while for the carrier that you're dealing with to set things up. I mean, you can go into Azure and you can create an ExpressRoute circuit, and that will give you a key that you then send to the carrier. And then the carrier may take a month or two to actually make that happen. Most people in internet time and cloud time want things to happen a lot faster. But once it's set up, it's very capable and very powerful. Service Bus. I mentioned Service Bus when we were talking about Azure Queues. Service Bus is an interesting capability that's been around since the beginning of Azure. It's got, again, multiple SKUs, standard and premium. It supports three. It's really a bundle of 3 services, 4 if you consider something else that I'm going to talk about later. But it's a relay service which lets you connect endpoints through firewalls. So, for instance, if you want to be able to connect to things in your data center and it's protected by a firewall, you could conceivably make an outbound connection to the internet from, on premises, connect up with an endpoint in Azure, and not have to initiate a connection from outside because you've initiated the connection from inside. And once you do that, if you think about things like WebEx, things like that, they actually work in that way. So it's very rare to have anything that will block that kind of communications. I mentioned queues when I was talking about Azure Storage. These are much more sophisticated queues. They can be priority based. They can be scatter and gather. They're much more sophisticated than Azure Queue. Azure queues are great for the simple front end, back end capability. These are much more capable and much more sophisticated. And the final thing I wanted to mention is Service Bus Topics, which is a way to do publish subscribe at internet scale. You can have clients that subscribe to a particular notification. Service Bus can send that notification to them. So it's very useful for that kind of application. Notification hubs are kind of based on that, although they're a separate service. Let's say that you want to send event notification to millions of locations. So, again, they would subscribe to notifications, and then when the event happens, you would send those notifications out to them. Again, very large scale. Think about things like some of the alert systems, like someone gets kidnapped and you get an alert on your phone to look for a particular kind of car. But building that kind of a system might be something you'd use notification hubs for. Okay, any questions so far? I realize I'm going pretty fast, and again, if there's anything that that you want more clarification on, you're going to have, at the end, I'll give you my contact information. If you have any questions or any comments, any feedback you want to give, just get in touch with me. I love that. Okay. Okay, security. Remember I said earlier that you can't afford in your data center to have as much security as Microsoft provides, and it's hard to convince companies of this sometimes. This is a diagram. This is one of 2 diagrams that I always show them. This one shows all the barriers to penetration that Azure has before anybody can even get at your stuff in Azure. In fact, I'm always nervous when I say this, but to my knowledge, I don't think anybody has hacked anything or broken through these barriers unless someone was extremely careless in their deployment so far. So far, okay? So at the outer barrier, there's distributed denial of service protection. You can't even get into Azure without opening up something called an endpoint. Virtual networks are isolated so that although this may be running on a common infrastructure, every company's virtual networks are isolated from the others. So there's a lot of isolation there. I mentioned there's network security groups. There's also something called user-defined routes. There are virtual network appliances, including the Azure Firewall and third-party firewalls. And someone would have to get through all of those barriers, all of those moats, to get to what you have running in Azure. This is my other favorite chart. And we don't have enough time tonight to go through this, but this is everything that Microsoft does to protect your stuff in Azure. They have a malware protection center, which is constantly, they're constantly developing, analyzing and developing threats to your systems. They have cyber hunting teams, and they have that are constantly trying to go after the bad guys. They have a digital crimes unit which works with the FBI and the CIA to go after the bad guys. They have a security response center. I wish I had included a picture. There's actually a picture I've got somewhere of the Cyber Defense Center in Redmond, which is enormous. They have a lot of services in Azure that have security features built in, and here's some of them, like advanced threat analytics. Azure Active Directory has security capabilities. Office 365 has a lot of security capabilities. Again, there's too many security features to actually go through in detail. Okay, I mentioned earlier, this is just a little more on network security group. Think of a network security group like a mini firewall, and you can put it on a VNet or a subnet or a network interface card, which you define in Azure on a VM. But typically what we find, we put them on subnets, so we protect things on the basis of subnets. So we might have a virtual network with a front-end subnet, a mid-tier subnet, and a data subnet. Put those kind of resources in those subnets. You specify inbound and outbound rules just like you do in a firewall. If you look at the sample on the screen, the inbound rules, basically this one says, okay, allow RDP traffic. Sometimes that's a little bit dangerous, but let's say that you're going to put this on a virtual machine and you want to be able to RDP into that virtual machine, remote desktop into it. Works on the basis of a tuple. There's a port, a protocol, a source, and a destination, and then the action. So for instance, what this is saying is, okay, I'll handle RDP. The next line is where I mentioned that things in a virtual network can talk to each other. That's what that's saying. That's saying allow the virtual network from in the virtual network to anything else in the virtual network. Load balancer inbound is where you're saying, okay, if there's a load balancer, allow that input in, and then finally deny everything else. And there are similar rules for outbound. The point is, it is really like a little firewall, and you could change that. For instance, if you took away that 1,000 entry, and this is all those numbers are all priorities. So things go down the stack until they have a hit, and then they stop. So if I didn't want to allow RDP access to a particular virtual machine, I'd just take that first entry out of the network security group. Trust Center. This is more on the subject of security. Microsoft has a Trust Center. They have more compliances. Excuse me, take a drink. They have more compliances than anybody else in the industry, any of the cloud vendors. There's just a listing of some of them. Okay. The Trust Center is a place not only to find all the compliance and security information, but also all the service level agreement information as well. So that's a good thing. I find that that's another link that you should probably have. I didn't include it here, unfortunately, but just look for the Azure Trust Center. Okay, now the big deal in Azure for security is Azure Active Directory. Now you're probably all familiar with on-premises Active Directory. What Azure Active Directory is Azure Active Directory is an extended subset of full Active Directory. It's a subset because it doesn't have all of the capabilities of on-premises Active Directory, but it does have a bunch of services for other purposes that are useful in a cloud environment. Okay, so this is enterprise scale identity and access management in the cloud. It's a subset. You can extend your on-premise directory to the cloud. In fact, you can link them together. There's a product called Azure AD Connect, which will synchronize all the identities that you have on premises or selected identities, let's say, if that's what you want, into Azure Active Directory and keep them in sync. So that's a good way to take advantage of some of that site-to-site VPN capability to actually have something called single sign-on, where your credentials in the data center and your credentials in Azure are the same. And there are two flavors of that. There's single sign-on and same sign-on. With single sign-on, the identities, you're actually authenticated in Azure. With same sign-on, you're also authenticated in Azure, but it's really just passwords hash synchronization. So you aren't automatically signed on, but it's the same user ID and password that you use both places. Multi-factor authentication has become really big because of all the exploits that are out there. What multi-factor authentication is based on the concept that you need more than just a password to access a resource in Azure. The old, I don't know if you've heard the way of explaining multi-factor authentication. It's based on something you have, something you know, or something you are, right? So it's, yes, you have a password, but maybe, you'll have to respond to a text message sent to your cell phone or an app that you have on your cell phone that you can respond. So it's just a way of adding more security to Azure. Okay, let's see what else. Office 365 integration. Yeah, well, Office 365 uses Azure Active Directory under the covers. Because Azure Active Directory is a subset of full Active Directory, Microsoft has started adding some of those extra capabilities to Azure Active Directory. And there's something called Azure Active Directory Domain Services. That's the capability to have virtual machines that join domains. You can have that now in Azure. If you have a business-to-business or business-to-consumer application, there's services in Azure that will let you use Azure Active Directory to authenticate users, for instance, that are in other businesses or even consumers. So there's some capabilities there. Let's see. There's conditional access where you can set things up such that if someone doesn't have a particular access privilege, you can give them that privilege for a period of time. So you can make that access conditional on time limited access or some other consideration. And of course, there are multiple levels of Azure Active Directory, and each one of those levels has different capabilities. So you do have to be a bit careful. For instance, something like self-service password reset, would require one of the escalated SKUs. There is free, which is really the one that's used by Office 365, and then there are basic and 2 premium levels. Active Directory Premium is is at the top of the list, and that gives you the ability to synchronize Active Directory with Azure Active Directory. There's self-service password reset, the ability to change your password in Azure and have that change replicated back to your on-premise Active Directory. Identity protection, which is something you can actually use to make sure that people aren't sending the wrong kind of data out into the wild. Like, let's say you can say, if this document looks like it has a credit card number in it, don't send it. Okay, and there's privileged identity management again. Again, there's more capabilities. I mentioned domain services. Again, it helps allow you to move more of those applications to Azure. You could install a domain controller in Azure in a virtual network, or you could take advantage of the on-premises domain controllers that you have to do the authentication. And you can even do domain join, virtual machines in Azure, even though there are no domain controllers in Azure, by using Active Directory domain services. Azure Security Center, really important. Again, I probably should move this slide up to the security discussion earlier. There's a great security center with a lot of capabilities, and Microsoft keeps moving more and more capabilities into Security Center. So when you run Security Center initially, you get the dashboard that looks kind of like that dashboard that I've got shown on the slide. So it gives you a security score and a compliance score. So it'll actually analyze the resources that you have in Azure and tell you if, for instance, you're not doing things the right way. And you can see there's red, there's red in there. For instance, you could get a warning if you have a SQL server, let's say, that's subject to SQL injection attack, vulnerable to SQL injection attack. So they do a lot of analysis. If there's a virtual machine in Azure that doesn't have a network security group on it or a subnet, they'll warn you about that. They give you a lot of suggestions. Some of those suggestions you can actually take action of in Security Center. There's some threat analysis software built into to Security Center, which will let you use all that stuff that those organizations in Microsoft have been collecting over the years in terms of potential exploits and issues. So they'll do analysis of potential threats. They'll let you generate real-time security alerts. So if you've got a situation that you don't want to happen, you can actually monitor for that situation and get an alert when somebody tries, for instance, to break into a virtual machine or log on. Here's an example: logging on from Nashville and then 5 minutes later from Zurich. Okay, travel time would restrict that. So either somebody shared their password or someone's trying to hack into what you've built. Okay. A little bit about threat analytics. Again, threat analytics is an interesting capability. There's two capabilities. There's threat analytics and advanced threat analytics. Advanced threat analytics lets you protect not only resources that you have in Azure, but also in the data center as well. Okay. And again, these are just some of the things that they that they do to detect, analyze, prioritize, let you handle various types of attacks and alerts. I mentioned information protection service. Again, this is the data classification and labeling, alerting, policy rules, and so forth. The security and audit, and again, you can drill this capability gives you a report of computers with cleaned event logs, computers with detected threats. Cleaned event logs may sound funny, but one of the things that hackers will do to try to break into a system is to eliminate all record of what they've been trying to do. So having event logs suddenly cleared when you didn't clear them is an indicator that something might be amiss. Okay. Also, you'll get alerts, you get information on missing security updates. Let's say you haven't kept your patches up to date in a virtual machine or a physical machine for that matter. Computers with guest login accounts probably shouldn't have those, so they give you alerts on that. And there's more conditions. That computers missing critical updates is important. If you're running virtual machines in Azure, or even if you're running virtual machines on premises, you need to keep your patches up to date. Remote RPC, remote procedure call, is a way that a lot of hackers will try to break into, your network. So they give you an audit report on that kind of information. Anti-malware, everybody's familiar with anti-malware with Norton, and Microsoft has something called Defender, which is a pretty good anti-malware product. No additional charge. You get that automatically. It's an extension that can be loaded into a virtual machine. May not do everything that a third-party anti-malware product does, but you can look at the features and make your own decision. Key Vault. Key Vault is interesting. Key Vault is a secret store. I mentioned that when we were talking about importing data into Azure, I talked about BitLocker and about encryption. And what Key Vault is Key Vault is a way to store secrets used by applications and services. Now, I'm sure no one out there has committed the crime of putting a password in a connection string or in a program in clear text. But that's something obviously you shouldn't be doing. So what you can do is you can actually store things like passwords, things like connection strings in Key Vault, and use that at execution time without actually having anybody able to see what the value of that data is. Okay. So it is compatible with the hierarchical storage modules standard. And one of the nice things about Azure is that if you encrypt your data, only you can decrypt that data. Microsoft can't do it. And the government can't make Microsoft do it. So it's very secure capability for, for handling secrets. Okay, let's roll on. Automation. Azure provides a lot of automation capabilities. I mentioned earlier that you can spend a lot of money in the data center for for servers that only run at 10 or 20% utilization. So one of the things that would be nice to be able to do in Azure is when something's not running at peak capacity, why not shut it down? And when it's not necessary, why not shut it down? So Azure automation can be used to automate the starting up and shutting down of resources dynamically. And it works with all of the Azure resources that you see on the left there. Okay. Here's an example of automation of Azure. And one of the key tools that people use to automate Azure is a shell programming language called PowerShell. It's a shell and a scripting language. There's a lot of arguments over whether it's a true programming language. I maintain that it is. There's a lot of folks out there that maintain that it isn't. Okay, so it is a shell and scripting language. It is object-oriented, and you can create pipelines and pass objects from component to component. You can use it to automate tasks. You can use it for configuration management. You've probably all heard the term configuration as code, or infrastructure as code. There are PowerShell commandlets for handling Azure, and this is just a snippet of an Azure script. That $cred is how you define a variable. Get credential is an AZ commandlet that basically lets you do a login in Azure. And then there are actually commandlets to let you create things like virtual machine scale sets. That's what that VMSS is, and so forth. And you can actually build a whole procedural process for creating things, for starting them up, for shutting them down. In Azure, I mentioned that PowerShell is really good for creating infrastructure, but it doesn't do an awful lot for configuring what's inside the things that you've created. For instance, you might create a virtual machine in Azure, put a subnet, put it in a subnet, have a network interface card, put it in a virtual network. But when it comes to deciding what to put in that virtual machine, that's where desired state configuration comes into effect. So I always joke that ARM builds the outside of the box and desired state configuration completes the inside and makes it stick. One of the interesting features about desired state configuration is that it can verify that things haven't been changed and make them back the way they were if someone should accidentally make a change to what's running inside a virtual machine. It has a lot of different uses for enabling certain specific server roles. Specific server roles and features. You can see the whole list there. Again, I'm not going to go through that. Installing software in a virtual machine. Okay, there's a lot there. There's a sample over there, which is basically showing that I've got this web server that I just built using PowerShell, and now I want to make it a web server. So let's make sure that IaaS is installed on that web server, and if it's not, install it. So that's PowerShell desired state configuration. This is the big thing. This is Azure Resource Manager templates. With PowerShell, it's procedural. It's imperative. You say create this, then go create this, then go create this. I call Azure Resource Manager the make it so service. Think about Star Trek and Jean-Luc Picard saying make it so. With Azure Resource Manager templates, what you do is you actually declare how you want your infrastructure built, and then you tell Azure Resource Manager to go build it. And they will build pieces of it in parallel, except where there are dependencies. So this is an example showing a virtual machine, and you're saying, okay, I got a virtual machine, I need a storage account, I need a network card to access the internet, maybe a public IP, and I want to put it in a virtual network. What you'll do is you actually define in JSON, in a language called JSON, the parameters that are coming in, and also the step-by-steps of how you want it to finish, not how you want it built, but what you want it to look like when it's finished. Now, a word of warning. Azure Resource Manager templates are kind of hard to use in some sense. I've done a lot of work with them. Microsoft is working on an internal product to build a language that sits on top of Azure Resource Manager templates. There was a discussion at Build last week about this. It's not ready for prime time yet. They're still, they're still in the design stage, but hopefully it'll be more of a programming language, even though it's declarative. My soapbox is that most programming languages have declarative stuff, and they have procedural stuff. So again, I've probably gone on way too long on this subject, but Azure Resource Manager templates are a way to just declare how you want things set up, and Jason will, Azure will do it for you, and they will do pieces in parallel, taking account of dependencies between things. For instance, if I were to create a virtual machine and then a storage account and then a network interface card and then a public IP and then a network, wouldn't it be nice to create some of those things in parallel? And that's what ARM templates do. Okay, backup. We'll talk about backup and disaster recovery. Azure Backup, not a lot to say about Azure Backup. There's an Azure Backup service. It is similar to if you're running in a big company where they use System Center. It's kind of like Data Protection Manager without the ability to do file backups locally, just to use Azure. There's a backup agent for files and folders. There's a special service for backing up virtual machines. Again, I'm not going to go, point by point. You can do, Azure Backup supports point-in-time restores. You can specify the frequency of backup and the retention periods. And you can also get application-consistent backups. So if you have a bunch of resources like virtual machines that have to be backed up together, like let's say you have a SharePoint server which consists of multiple virtual machines on premises or in Azure, you can make sure that they all get backed up together. Azure Site Recovery is one of my favorite capabilities, maybe because I've used it a lot. It is used for disaster recovery, and it has always been used for migration as well. Although nowadays there's a product called Azure Migrate that's becoming more and more into vogue. But what you can do is, you can see from the chart, you can do disaster recovery between almost anything to anything. Like this shows that I've got a VMware, or Hyper-V, or physical machines. I can do DR into Azure. I've even got Amazon Web Services virtual machines that you can do DR into Azure. It will also orchestrate the disaster recovery between multiple data centers running VMware or Hyper-V. So it's pretty cool. I've actually migrated Amazon virtual machines from Amazon Web Services to Azure using Azure Site Recovery. Microsoft is in the process of taking most of those capabilities out of Azure Site Recovery and putting them into Azure Migrate, but still useful for migrate scenarios. And you can see all the different workloads that that it supports. Okay. Basically, what you do is, I don't know if I have a slide. I guess okay. I have a slide on Azure Migrate. This is the entry screen to Azure Migrate. Again, Azure Migrate is a front end to a lot of different migration tools, some of which we've mentioned already. The first one, Access and Migrate Servers, that's the migration tool for migrating virtual machines and SQL servers, from on-premises into Azure. Assess and Migrate Databases, we mentioned earlier, that's an entry to those assessment tools that I mentioned earlier, that you can do an analysis of your database and move it to either SQL database, SQL managed instance, or so forth. Okay. This one on the right is relatively new. This is a tool to help you take that web application that you have in your data center and migrate it into Azure. Okay. So this will let you, if you have a .NET web application, it'll move it to App Services, which is very, very useful. Notice down here, there's order a data box, okay? If you have to migrate large amounts of data to Azure, you can actually go in here from this screen and get, have Microsoft ship you a data box that you can put your data in and ship it up to them. Let's see. Okay, enough on migration. New product from Microsoft, Azure Windows Virtual Desktop. With everybody working at home now, there's more and more demand for companies to support remote workers. So there were always products to do this. There were products like remote desktop and remote app. And then Citrix had a product that helped you do virtual desktop. But what this is an interesting product because Microsoft has taken advantage of some of the PaaS services that they already support. It used to be that to create a virtual desktop or VDI type of environment, you actually had to create a bunch of servers for web access and service brokers and gateways and load balancers and actually build it with IaaS components. Now Microsoft has bundled a lot of those components in a PaaS layer. So for instance, all you really have to do is use those capabilities. There's a new version of Windows, by the way, that Microsoft just came out with that can support multiple users at the same time. Now, Windows Server has always been able to support multiple users, but Windows Server just doesn't look and feel like a client Windows operating system. I mean, I've run it that way. I've done that. I've used Server as my operating system, but it's a little bit just different enough to make people upset that it's not behaving like regular Windows. Now there's a version of multi-session Windows out there where it will support multiple users at the same time. And again, we don't have time to go into the detail, but there's some very sophisticated architecture around virtual desktop. Giving everybody their own environment, giving anybody their own data space, giving people dedicated virtual machines for high performance requirements or shared virtual machines for large numbers of people using the same virtual machines as a pool. All right. What was that? Okay. Oops. Okay. So again, it lets you create a virtual desktop infrastructure and scale it up very quickly. It's got support for Windows Server if you happen to be migrating from Windows Server, but that new multi-session Windows 10 version is probably the way to go. There's also, believe it or not, Windows 7 support. What they're trying to do is support Windows 7 as a migration tool to get people to upgrade from Windows 7. And if you look at the diagram, you can see that what you've got there is you've got all those components that support it in a PaaS service. Okay, keep going. Intune, if you're in a big environment, you typically manage devices through System Center, and the device management part of System Center has basically been migrated into Azure, into a product called Intune, which provides mobile device management capabilities. And again, there's a lot of features like enrolling devices, provisioning and providing remote assistance, managing those devices with updates, configuring and securing them, security capabilities, all related to the management of remote devices. Big data. I have to admit off the bat that I am not an expert on big data, although I've done a few big data projects in my career, nothing significant. HD Insight is a capability in Azure. If you've ever heard the term Hadoop or MapReduce, it's a way of breaking up applications into lots of little pieces, having the computation done in parallel, then bringing all the pieces back together again. So it's good for distributed processing of a large set of data across a big cluster of computers. It can scale up from single servers to thousands of machines, and it supports all the typical programming languages that data wonks use to do their processing. Languages like R and USQL and Python, as well as open source products, things called Storm and Spark. Okay. Uses a file system called HDFS, which is kind of like NTFS, but unique to big data, and so forth. See, Data Factory is interesting. One of the features that SQL database and SQL managers do not support is SQL Integration Services, SIS. Anybody who's worked in, the kind of environment that we've all worked in the data center knows that you build you build ETL pipelines, you build extract, transform, and load pipelines using SQL integration services. Well, Data Factory lets you do the same kind of thing. Okay, there's data lake storing and analytics, a few other capabilities. Again, I know it's getting late, so I'm gonna roll on a little bit here. Machine learning. There's a lot of stuff in machine learning for analyzing data, training the data, determining what's going to happen in the future based on what's going to happen in the past. Again, I don't want to spend a lot. Power BI lets you build dashboards and lets you incorporate that into Azure capabilities, into Azure applications. Internet of Things is a big deal in Azure. There's billions of devices we're headed towards out there that send telemetry back to locations that need to process that data. And again, I won't beat this to death. Microsoft has a whole reference architecture. This is pretty cool. If you hear about bots and applications that emulate people, that's what Cortana Intelligence Suite is useful for. I did want to show you this. This is CaptionBot.ai. This is a great example of a bot. If you give this if you go to this website and you upload a picture, it will actually write you a caption for that picture. For instance, that picture, they created the caption, I think it's a car driving down a busy highway. It just blows my mind that they could actually figure that out. Now, what I did was I uploaded a picture of a very crowded highway, and they didn't quite get the caption right. They said, I think this is a car in a parking lot. And after a while, I just had a good laugh and decided that, yeah, they were really right. Might as well be a parking lot. So if you have a few minutes to have some fun, just feed some pictures up to that application. Okay, we're getting to the end now, which is good because I think folks are starting to fall asleep. But multi-platform development tools, there's a lot of tools in Azure. The main development tool is Visual Studio, although an open source cross-platform version of Visual Studio called Visual Studio Code is gradually resuming more and more and more of the development workload out there. Visual Studio, and it runs on Windows. Eclipse runs on a Mac, but Visual Studio Code runs on OS X, Linux, Windows. Microsoft has ported PowerShell to Linux. The Linux Bash shell now works on Windows. There's a cross-platform command line interface, CLI, which can be used to manipulate resources no matter what platform you're on. And Microsoft last week just announced something called Visual Studio Code Spaces, which is where you don't have to have anything installed on your PC. Everything is done in Azure. So you can actually create applications and test applications without having anything on the PC that you have at home. Interesting solution. Okay. Microsoft Azure comes with all kinds of software development kits for all those languages and platforms that you see there. Azure DevOps is special capabilities for building sandboxes for developers to work in. There's Git support as part of Visual Studio. There's DevTest, like I said, there's DevTest Labs was that you build those sandboxes. Again, I want to kind of wrap it up. Okay, great. The whole point here is that there's a ton of resources in Azure. In fact, more than you'll ever need. So you really have to look at all the resources that you have available in your toolbox and then decide what problem you're trying to solve. Really, the business problem is the most important thing that you're trying to solve, okay? So a lot of it is the business problem. Second consideration is what you're comfortable with using in terms of tool, be it Microsoft tools or open source tools. Okay? Fundamental concepts we've talked about, virtual machines and scale sets. We've talked about web services and web apps. We've talked about serverless computing functions. We talked a little bit about containers. We talked about virtual networks and so forth. Again, available in 140 countries, and it keeps getting better. Oh, one thing I didn't mention, there's also a completely separate Azure cloud for government use. So there's commercial cloud and there's government cloud. It's not quite as big. It's not as big as the commercial cloud, but it is dedicated and isolated from the commercial cloud. So if you're a state or local government or federal government, you might want to use that. It is not 100%. It doesn't have 100% parity with the commercial cloud, but they are getting there. How you get Azure? There's a 30-day free trial. You get a small amount of free usage. You need a credit card. That's just for fraud protection. They won't charge you for anything unless you say, okay, convert this to a paid account. If you have an enterprise agreement in a company, you're already getting Azure resources as part of your enterprise agreement. You might as well take advantage of it. Various ways to buy Azure through open licensing from Microsoft partners. There's Visual Studio subscriptions, which are a really good deal. They were previously MSDN, Microsoft Developer Network subscriptions. You get a certain amount of Azure each month as long as you have the this service. Again, you have to sign up for it. And if you are an enterprise, like I say, if you are an enterprise agreement customer, you're already paying for it, you might as well use it. There's also a new offering called Microsoft for Startups, which gives Microsoft Cloud Technologies free to companies that are just starting up. And there's Action Pack for partners, which gets you a bundle of Azure resources. Again, go out to you can find all this information on the Azure website. Some references that I've found that are really good. Channel 9 videos from the latest Igniter build. They're starting to post those build videos now from the previous 2 days of build. So you can take a look at the these sessions that they had, and you can look at the recordings from some of those sessions. Free trial, we mentioned. Pricing calculator, Microsoft for Startups, and again, use the EA benefits that you have. Here's some good references. The main Azure website is azure.microsoft.com. The Azure Management Portal is portal.azure.com. All the Azure documentation is at docs.microsoft.com/Azure. I did a blog post with a whole bunch of references a while back that you could take a look at. Although it was in 2016, so it might not be up to date now. And that's it. This is a picture, a self-promoting picture of my blog and my contact information. So if you have any questions on anything we talked about, just get in touch. All right. Anybody have any additional questions? I know we've lost a few folks. So.
Oh, thank you. Thank you, Bill.
Okay. Well, thanks for attending. Yes.
Leroy Thomas, quick question. In the future, do you think y'all be covering any of these classes covering Power BI through Azure?
I don't, but there are a lot of Microsoft classes, and there are a lot of you know what? Do me a favor, drop me a note. I'll forget by tomorrow. Drop me a note at wzack@live.com, and I'll see what I can dig up for you, because there are a lot of free things out there.
Okay, thank you, Bill.
Okay. Any more questions?
Yeah.
More questions?
By any chance, we are just trying to do that one-day training session, what we planned during April, right? So everyone is now online. So
okay, I can't hear you. There must be something wrong with your microphone. Do you want to throw something in the chat?
Okay, I will maybe email you or.
Okay, why don't you email me and I'll get you. I promise I'll give you guys a response quickly. Okay.
Sure. Thanks, Bill.
Okay. Any more questions before we break off?
Bill, this presentation, you have it on your blog, or you will send it?
What I'm going to do, we have a YouTube channel. So what I will do is I will post the video on the YouTube channel. What I'll do is I'll probably move this to, let's see, put it to my Windows Live account and send a link to the group.
Yeah, good idea.
Okay, because I want everybody to have the deck too. Okay.
Yeah. Thanks.
Hey, Bill, that YouTube channel y'all have, do you have the where I can subscribe to it?
Yeah, it's if you look at the hang on, let me. Time travel. Hang on, come on. We're getting there. Oh, forget it. Okay, wait a minute. Oh, you know what? It was on the other. It was on the other deck. I'm sorry. Hang on. Hold on a second. Let me just do this.
Let's see if you can.
Let me just show you this screen. Come on, come on. Come on. All right. Why am I not? Now I'm getting angry.
I just found your site on YouTube. I'm gonna copy the link on the chat so they will see the button to subscribe in the top right corner. I just paste the link on the chat. I think that is the one.
Okay.
Thank you.
All right, good. Okay, guys, I'm gonna end the meeting. Hey, thanks for coming and thanks for sticking with us. I appreciate it.
And thank you for your time. I really appreciate it. Thank you very much for your effort and time for this meeting.
Okay, you're welcome. Thank you.
See you next time. Bye.
See you then.
Stay safe.
Yeah, you too.
Bye.